All right, hey students. Here we are. We are going to be doing recording here. I'm just getting this camera as close as I can to the paper. Oops, sorry, earthquake. All right, so we're going to cover now 1.3 rotations right here. Okay, and again, we got another one of these boxes. We approximately have two more after this. So if you're doing this at home, I do apologize. So yeah, now let's get started. So we need to talk about rotations. When we talk about rotations, we're talking about moving an object around, be it some kind of focal point. When you see a motorcyclist jump and do a rotation in the air, they call it a 360 or a 180, which then he has to land backwards if he did that. So is the case, but we'll talk about all those kinds of positioning. So let's say that I start with an image that, and I'm going to be referencing back to my previous page from the last notes, mainly just to get the colors consistent for you guys. So let's say I've got a point at B is at 4, 0, 4, 1, 2, 3, 4. So he's up here. C is at 1, 1. And A is at negative 2, 3. 1, 2, 1, 2, 3. Okay, so there's my current triangle. Let me connect them up together. Okay. There we go. So again, there is my B, A, and C. And of course, that is going to act as my pre-image. Where A is going to be negative 2, 3. B is going to be 0, 4. And C is going to be 1, 1, right? Okay, and our goal at the end of this is to get a image of the following. Okay, where A prime is going to be 3, 2. B prime is going to be 4, 0. And C prime is going to be 1, 1. Or 1, negative 1. There we go. Okay, so obviously some transformations happened here. Take a note in noticing that C, a negative showed up. A, they flipped, and so did B. So maybe it might involve flipping the points around, making something negative. We'll go over that in detail. So if we plot these points, right, we have 3, 2. So we're going to go 1, 2, 3 up 2, 1, 2. So he's right here. There's A prime. Okay. B is all the way over at 4, 1, 2, 3, 4. And C is over 1, down 1. Okay, so here is our new triangle. Okay. Now, I find that rotations are the hardest to do, which is what we're talking about, because you have to think about this from where it's rotating around. So obviously our rule is flip and change back. We flipped and then changed back. We flipped and then changed back. We flip and change back. And change back, I mean changing it to a negative. So our rule is going to be flip and change back, aka 270 degrees. So what I mean by that is that if we were to take essentially our ruler here and we were to connect C to the center point here, let's call that center point, give it a different color. We'll call that center point R. I'll use dark green for it. Okay, let's call that center point R for a second. Okay, and the reason we're going to call it R is because if we were to hypothetically connect this point to this point, and this point, we can find that those lines are congruent. How do I know that? Well, let's take a look. If I were to connect them, I'll use dark green for this. That's what I used on the last page. I used purple. Oh, I'll use dark green for this guy because we're using rotations. Okay, if I were to draw some dashed lines to connect these C's together, okay, you'll notice a right angle forms. because they're perpendicular to each other. That means that if we use basic geometry from angles, if you remember that a right angle is 9 degrees, a full rotation is 360. 360 minus 90 is 270. How about that? So if we were to go around here and address this angle, that angle would be indeed 270 degrees, right? So there we go. 270 degrees, full rotation, checks out. Therefore, this shape rotated 270 degrees. And we can do the same thing for every single one of these points. I'll do some examples on this page over here to show you what that looks like. Whoops, I dropped my pen. Oof, and I just bumped the bar. Sorry. Apologies. But I'll show some examples of what that looks like, but that should make a lot of sense now. So if you can rotate all the way around. This means, and we'll make a note of this here in a little bit, that CR is congruent to C prime R. Why? Well, they both have a slope of 1 over 1 over 1 over up 1 over 1, so that means lines are congruent. A would follow the same thing, B would follow the same thing. Their slopes will be congruent. B doesn't even have a slope, it's 0, so that totally makes sense. A, if we connect A's back, they should have the same slopes. So you'll find that this will result in lines being congruent, and if they're congruent, that means they have to be perpendicular. If they're perpendicular, then they are 90 degrees. So let's move on then to the algebra section, right? So algebra's got some weird stuff going on, okay? And I'm just referring back to my notes above here. Okay, so let's take a look at the algebra section next. Okay, and here's what we do know about this guy. So we know that our rules, okay, are going to be here. And we know, I gotta sneeze, hold on. All right, apparently not. It said it went up my nostrils. You know, you ever get that burning sensation? Ugh, it's the worst, right? Anyway, so let's take a look at what our rules are going to be. So we are going to have our original and to get. We've got the original, and we have the rule. Okay? And there are a couple that we have to take a look at. So obviously our originals, there are going to be 4 possibles. Okay, so we have our X and Y. And for this first one, we're going to have, and I'm going to write the degrees in purple, 90 degrees, okay, 180 degrees, 270 degrees, and of course, 360 degrees. Okay, respectively for each. And all of these are going to start at the same spot. X, Y. Okay, nothing new there. Okay, so what we need to figure out is what we're going to get out of it, right? Like what's going to be the outcome from all of these. So what is this going to become? What is this going to become? What is this going to become? And what is this going to become? Right? So here is what our rules are. For the first one, for 90 degrees, it is actually relatively easy. We're going to flip them around and make the front number, aka y, in this case, negative. We're flipping the x and y around, making them negative. For the next one, we basically just flip the terms, which makes sense. If I were to rotate this 180 degrees, it's going to end up in the opposite location where it is. This is not a perfect reflection, though. It's like I like to refer to 180 degrees as the discount reflection. Okay? 270 degrees, it would then be y negative x, our flip and then change back. Change back meaning the change back number, okay, the back number here. You might want to make an annotation of that and say, like, you know, back number. In fact, I think I'm going to do that. I'll put a asterisk next up to here. And what that basically means is that asterisk means back number. Okay, so there we go. And then of course the last one, which is xy, and surprise, surprise, it's xy. There's no change. It doesn't do anything because we're just going to rotate back to where we started. You will never have a question that's just 360 degrees. Spoiler alert, that's too easy. I can't give that to you. All right, now let's move on to descriptions. Oops, I just moved the whole camera. All right, descriptions. So for descriptions, okay, here is each of these guys, okay? So for the first one, whoops, I can't go sideways. I have to go sideways. So to rotate, okay, so if we want to rotate, okay, all right, so with these guys, when we want to rotate, things are relatively going to stay the same across the board. Unlike our previous one in translations where we had X and Y's, in this case, we don't have an X and Y. They're all being affected simultaneously. Really, the only thing we have is the individual degree values. So I will do this in purple. So for our first one, 90 degrees, okay, you flip X's and Y's, then negative front number. Okay, for 180s, okay, negative X and Y values. For 270, okay, sorry if you're hearing sirens outside. You're going to flip X and Y, then negative front number. Okay, so far so good. And finally, well, you can guess what's going to happen with 360 degrees. Okay, guess what? There's no change. Okay. No change. It's just the same. Now, there are, of course, two asterisks, or one, yes, a star down here. Sorry, not an asterisk, a star. So let's do this star in, I'm trying to think of a color I can use for this. Let's do it in, what color did I use last time? We'll use red again. So here is an important star down here. Okay. If it is clockwise, okay, do the counter equivalent. "90 degrees counterclockwise becomes 270 degrees counterclockwise. I think I said counterclockwise here. Sorry, I meant to say clockwise. And 270 degrees clockwise becomes 90 degrees counterclockwise. Okay. So big surprise, there isn't much of a change. I just realized that this shows up as orange on the document camera, but it's actually red IRL. I found that very interesting. Must be something with the camera. Anyway, the point is that this is a very important point. Another star that I think, I didn't go over this in class, or I didn't say this in class, but one thing I probably should state is that unless it says otherwise, you will always assume counterclockwise. So let's make that. Unless it states clockwise, always assume counterclockwise. Okay, so unless it states clockwise, always assume counterclockwise. Okay, so that's just another big star here that you can always assume on. Now, finally, we're up to definitions. Last one, and then we'll do some examples over here that I have saved from class back in the day that I thought were really good, that actually you guys as students came up with. Some of you guys might recognize them if you're watching these videos to study right now. which I hope you are. Okay, so definitions. Let's talk about some definitions. Okay. First point we need to talk about here is that this is a turn. Don't overthink it. Okay. There is a change in position, a change in orientation, and finally, the figures are isometric. Okay? Now, two big stars down here. Star number 1. Point of rotation is R00, 0, and will be that always. Next up, and I said this over here, but I'm going to say it again, counterclockwise. Counterclockwise, quadrants. Okay. There we go. So that is the other major point. And finally, okay, and this kind of comes back to our graphically example down here again. So I will write this actually down here, which will make a lot more sense. Okay. Sorry, I'm trying to get it in frame. There we go. Okay. Okay. Whoa, camera's wigging out. Come on, focus up. It's freaking out because of the light issues. Why does it look like a rave? Stop. Stop looking like a rave. Hold on, I gotta focus. Okay, there it goes. So that was weird. I do apologize. So there is, of course, one big star at the bottom. We'll do this one in red, wherever my red pen went. It's slid underneath my book. Okay, and here is our last star, okay, which is that AR, line AR, is congruent to line A prime R. BR is congruent to line B prime R. And as I've already shown you, CR is congruent to line C prime R. Okay? That is literally it for that one. Oh, God, stop. I don't know why it keeps flashing. Maybe the camera's dying. I do use this thing a lot. So, all right, guys. Hopefully that was helpful. That's not what I wanted to do. There we go. Hopefully that was helpful. I'm going to do some examples over here now, so stay tuned for those in the next video. Thank you.